Okay, so on worksheet 12B, we're going to do the product property of radicals and the quotient property of radicals. These are just some properties I've already talked to you about again, except that we're kind of going to look at them the way we break them up, and we can go forwards and backwards so we can simplify radicals. For any real number a and b and any integer bigger than 1, if n is even and a and b are both non-negative, meaning you don't have a negative number underneath the radical, then you can separate them. The root, this is, okay, one thing I want to say is, do you know this is called the index, right? The index is that n value there. Okay, that's what kind of root it is. So if there's no index, it's a square root. If there's a 3 there, it's a cube root. If there's a 4, it's a fourth root, and so on. You can break up the number that's under there into a product and then separate them so that you can simplify the radical. And you can also go backwards and multiply them. If the indexes match, then you multiply the numbers underneath. If n is odd, then you have the nth root of ab. It looks like the same index thing to me. Okay, so let's not worry about that part too much. All right, we want to simplify a square root or a cube root or a fourth root. You factor the radicand into as many possible, not squares if it's something else, but right here, don't cross that out. I didn't really mean to. Most of the ones we're going to be doing are square roots. You would factor it into as many squares as possible. Use the product property to isolate the perfect squares and then simplify each radical. Now, if it goes to cubes, then we got to find perfect cubes. If it went to fourth roots, we're going to have to find fourth powers. I'm going to pause just a moment so I can pass out a chart. Okay, now that you have one of those charts, let's go down to the quotient property, which I brought up also before. If you have a fraction, which is a quotient, division of two numbers, you can split it up. If it's a whole fraction, you can split it up into a radical over a radical, or you can go vice versa, go from here back to there. All right, so to eliminate radicals from a denominator or fractions from a radicand, multiply the numerator and denominator by a quantity so that the radicand is an exact root. What that means is, remember how last week we had, say you had 2 over the square root of 3, and you wanted to get rid of the square root of 3 in the basement because you don't want radicals in your basement. They might blow it up. Remember that? What do we multiply by? Oh, thank you. Square root of 3, top and bottom. So this would have been 2 root 3 over 3. That's what this is about, getting the radicands out of the basement. All right, let's do some examples. So if we're multiplying this, one rule I need you to remember is x to the n times x to the m. Can we watch the noise with our snacks, please? It's very distracting to people. Base times base, what do you do with the exponents? We're going to be doing exponent rules tomorrow, but I still need you to know some of the basic ones. What do? Combine them how? By, you add them. Yeah, you add the exponents. So if I were doing this problem, I could do the square root of 36x to the 4th, which is x squared times x squared. I mean, I don't think you should have to write it out like that because I already taught you if the index is 2, you're going to divide that into here. All right, the square root of 36 is 6. Square root of x squared is x. The square root of another x squared is x, so it's x times x, which is x squared. If this is identical and you multiply a radical times a radical and they're both roots of 2, then you would just get the exact answer that's under there, okay? So anything times itself, the radical drops. Assume each value of the variable is positive. They did tell us. So this one, we're going to go ahead and multiply. Since these are both an index of 2, we can multiply what's underneath the radicals. 3 times 12 is 36. X to the 4th times x to the 3rd is x to the 7th. You add the exponents. Now we'll just do the property that I explained to you the other day. The square root of 36 is 6. This is an index of 2, so I go 7 divided by 2 goes evenly 3 times, but someone got left. There was one remainder, so you have a square root of x left. So it's 6x cubed times the square root of x. Now, what we need to remember is something we talked about on Friday. Remember you had your tree? And where were the roots? The roots were in the basement. So I'll actually make some brown roots in the ground. Okay. Now, the power of the tree is above. So that was the power over a root. And this power would have been a 1. And the root is a 2. So this is actually the square root. 1/2 as a exponent means the square root. Okay, so this is just like doing the square root of 15 x to the 4th y to the 2nd times the square root of 5 y to the 6th. Okay, so we're going to go ahead and multiply what's under the radical. And 15 times 7 is 75. X to the 4th, y to the 2nd times y to the 6th is y to the 8th. And now I'm going to break apart the 75 into a perfect square times a non-perfect square. What would be the perfect square number that divides into 75? Okay, so 25 times 3. I got x to the 4th, y to the 8th. Okay, and then we would do 5. X to the 4th, the square root of x to the 4th would be x to the 2nd. 4 divided by 2 is 2. Y to the 8th, taking the square root of y to the 8th would be y to the 4th. 8 divided by 2 is 4. And then what's stuck underneath there, it was simply the 3. And that would be the end of that one. Kelsey, don't forget to pick this up for me before you go. Anybody still need this? Okay. Number 4. Now, this will be going in backwards of the quotient property. I already have it separated, but it doesn't look like it would be much fun to do this the way it is. Okay, so I could rewrite this as a fraction. Oh, that was so loud. The air conditioning. Oh, it's just very noisy. Now it seems like it's really, really quiet. Okay, so what can I do that would make this a little bit more fun? I know it's not fun. I got your attention at least. All right. 4 divided by 6 is, I thought you were going to go home and for fun and entertainment and call your friends over. All right, now, tell me this, guys. Let's not get too off track, please. I'll make a joke, but then it's got to end. What do I do when I divide exponents? Yes, sir, Cameron. N minus m. You would subtract the exponents. So what's the exponent on an x? It's just a 1. So if I subtract 1 from 4, I'm going to have x cubed under here. And then I have x to the 6th divided by y to the, y to the 6th divided by y to the 4th. Subtract 4 from 6, we get y to the 2nd. And now I'm going to simplify this. So the square root of 9 is 3. The square root of x cubed is x with 1 left over. The square root of y squared is y. And then we'll have a square times the square root of x because one guy got left behind. That's our answer to number 4. Okay, with all that in mind, I'm going to rewrite this next one as a big old cube root. I'm going to have 108 on the top, a to the 15th, b to the 10th, and then on the bottom, that 1/3 power means the cube root. So it's just 2b on the bottom. Okay, 1/3, that is a cube root. So I'm going to reduce this. 108 divided by 2 is 54. I got an a to the 15th, and then I have a b to the 1st on the bottom, so I'm going to take away 1 from the top and get b to the 9th. Is everybody okay with where I got this from? If you don't understand, please raise your hand if you want me to re-explain how I got b to the 9th on this problem, or y to the 2nd and x to the 3rd on the last one. Okay, now, yes, Logan. The 1/3 means the cube root. That's why I was able to put 2b on the bottom and put this all in one big cube root. Okay, 2b to the 1/3 means the cube root of 2b. The root is the denominator, and that's the power of 1 on the top. Okay? A half for an exponent is square root. A fourth would be a fourth root. A fifth. Okay. Now, we have to do a cube root of 54. It's not square root anymore, so I'm not breaking this down to 9 times 6. I need a perfect cube. I gave you a table. Find it. 3? 3 what? You gotta tell me, explain what you mean. 27 is a perfect cube. Thank you. Okay, what is 54 divided by 27? Well, that's 2. That's why you used 27, because you found out 54 divided evenly by 27. I have to have a perfect cube times a non-perfect cube. And now I can simplify this. The cube root of 27 is the number 3, like Addison said, but he didn't want to explain it. So then 3 goes into 15. 5 times, we got a to the 5th. And then 3 goes into 9. 3 times, we got b to the 3rd. But something got stuck, and it was the 2. Something is wrong with my answer right now. Gwen, right? Yes, you have to write the index. Good job. So we have to have this 3 index on our answer. If that's missing, half a point off on the quiz. Okay, number 6 is, nothing can reduce. So let's do it the other direction, where we're going to break up the numerator from the denominator. They're going to break up with each other. Okay, on the bottom, I know, isn't that sad? All right, in 45, perfect square times non-perfect square would be 9 times 5. And I'll leave that y to the 5th. Hey, we have a question. Did I go too fast on the last one or something? No? All right. So let's stop chatting. All right, square root of 4 is 2. Humming needs to quit. Square root of x squared, Scott, really? X. All right, something, it wasn't you? Okay, sorry about that, guy. All right, 2 stuck there. I don't know, I still think it might have been. All right, the square root of 9 is 3. The square root of y to the 5th is y. Well, 2 goes into 5 evenly twice with 1 left over. So then I've got a 5 and a y left. So we still have a problem, Houston. How do I got to get this guy out of my basement. He might blow up. By the square root of 5y. Yep. Okay. Now, I'm slowing down. I want you to understand. First, I had to, you guys need to stop chatting. I'll play this back for your parents and I'll use your names. All right. Kidding. Okay. You guys, we got to multiply the top, and it's all you do is just multiply radical times radical part, right? So we're going to have a 2x. Get this out of the way. We're going to have a 2x and a square root of 10y on the top. On the bottom, when we multiply 5y times 5y, the square root of 5y times the square root of 5y, we get the square root of 25y squared, which is 5y. Okay, something times itself will be 5y. So I've got 3y squared times 5y on the bottom. Okay, now if you understood it very well, you wouldn't have to write this step, okay, but this is new to a lot of you. So my final answer, 2x times the square root of 10y all over 15y to the what? 3rd. You cannot cancel out any y's. That one's stuck into the radical. This is done. It's not reducible. I know that that was a lot to put in that space, especially because I wrote out a lot of steps, and I apologize you didn't have more room on your paper. I hope you didn't have to do 2 swirly little arrows all over the place to know how to follow it. But This next one's even worse. So guess what? Because I don't really need to teach you how to do that one today, I'm going to hold off. Okay? This one is harder than any of the other ones we did to rationalize it. Okay? So I'll come back to this. Would you just remind me possibly tomorrow after I do exponent rules? Maybe we'll come back and just do this guy. I think you had enough of those for right now. So the next thing, because this is pretty intense too right here, is doing operations with radicals. You may never have done anything like this before. But I want to give you a little insight into a couple of things to think about today. What happens when you multiply this? You don't have to write this down. You can just think about it. What happens? Okay, so what's my point? How do I get rid of a middle term? If I start with that, how could I get the middle term to drop out so when I multiplied by something? Multiply by this. Okay, it has a name. They're called conjugate pairs. Okay, you're going to need to know the word conjugate. The conjugate of x minus 2 is x plus 2. The conjugate of x plus 2 is x minus 2. All right, they're identical except the sign in the middle. That's it. They are not opposites. Opposites would be completely opposite. These are not completely opposite. It's just the middle sign that's opposite. So if I multiply these guys, it's a little easier than maybe you think. So if I do the square root of 11 times the square root of 11, that's 11. I'm going to write it out the long way this first time. I'm going to multiply the square root of 11 times the square root of 13. That's going to be plus the square root of 11 times 13. I didn't even bother to figure out what that is. Then I'm going to do negative square root of 13 times 11. That's going to be minus the square root of 13 times 11. And then last, negative square root of 13 times negative square root of 13 means negative 13. Okay, negative times positive is negative. Remember, if you multiply matching numbers, the radical disappears, because that would have been the square root of 121, which is 11. Or square root of 169, which is 13. All right, now, what happens in the middle? They're opposites. So all I really got is 11 minus 13, and the answer is negative 2. That whole mess turned out to be just negative 2. But not all of these are conjugate pairs. So we have to go through the process of multiplying it out. If it's a pair times a pair, you do have to have 4 terms. Okay? Let's try number 9. 2 root x times and root x. That's going to be 2x. 2 root x times negative 4 is minus 8 square roots of x. Now I'm going to do 1 times both of those, which is going to be plus square root of x minus 4. Okay, I'm going to combine any like terms. I've got 2x, nothing to go with it. I have a negative 8 root x plus 1 root x, which would be minus 7 square roots of x, plus, oh, was it minus 4? And I can't do anything else because they're all unlike. Are we okay? Anybody not know where I got something from when I multiplied? All right, then, we'll march forward to number 10. 3 root 7 times the square root of 7. Square root of 7 times square root of 7 is 7. So I actually have 3 times 7 minus 3 times 7 times 14. I'm just showing you that what I'm doing. That's 21 minus 3 times, wait a minute, there's a 7 inside that 14. I got 98 here, right? What can I break 98 down into? $14 is 7 times 2. 49 times 2, and 49 is a perfect square. So I've got 21 minus 3 times 7 root 2, which is 21 minus 21 root 2. I showed a lot of details. Yes. Where? Oh, well, maybe I could make you realize why I can't put those together by saying, could you put that together? Okay, good. No, that's what I just need the light bulb to go off. Good job. I saw it. Your face just went. Okay. Perfect. That makes sense. And these are attached, so you can't, they have to stay married. Yep. We'll have more of that later in the future when we have to do fractions, expressions, rational expressions. All right, here we go. Whoosh, boom. 2 root 3 times root 3 would be 2 times 3, or you want me to write it out? 2 times 3. Okay, this one would be outside times outside. Oh, remember, if you're outside a jail, you can hang out. If you're inside jail, you get to hang out. So multiply the numbers on the outside, multiply the numbers on the inside. So 2 times 2 is 4. Square root of 3 times square root of 2 would be square root of 6. Okay, now I'm going to go this way. Negative 4 root 2 times root 3 would be negative 4 root 6. And negative 4 root 2 times 2 root 2 would be negative 8 root 4. I guess if you want me to, I could write that. This I could have written the square root of 9. You see how I'm just going to bring it out anyway? Yes? Can I write 2 instead? Okay, minus 8 times 2. Square root of 2 times square root of 2 is 2. Okay, now, 2 times 3 was 6, and then the middle terms, look, oh, they're opposites. Wackadoo, get rid of those. And then negative 8 times 2 is negative 16, and now I just have 6 minus 16, so my final answer is negative 10. A lot of stuff. All right, it says to square this. Square root of 2 minus square root of 6 times square root of 2 minus the square root of 6. You can always expand it out. Or you can do my shortcut method for squaring a binomial. Square root of 2 times square root of 2. Then you can do this times this and double it. And then you can do this times this. That's the shortcut. You don't know what I'm talking about. If I was squaring this, here's a shortcut. X times x, x times 1, 1x, double it, plus 2x at 1 times 1. That's a shortcut. If you get it, you can use it. If you don't, I'm just going to go ahead and multiply this out. You want me to do it again? Watch, I'll change it. X times x, x squared. X times 3, doubled, 6x. 3 times 3. Because you always get 2 of those. Okay? Anyway, if you get it, you can use it. If you don't, you can expand it. All right, so let's do square root of 2 times square root of 2 is 2. Square root of 2 times minus square root of 6 be minus the square root of 12. But we're going to end up with 2 of those. That's what I was talking about. And then negative 6 times negative square root of 6 times negative square root of 6 is plus 6. So I add 2 and 8, and I get 2 and 6 and get 8. I gotta slow down and stop saying things wrong. This is 2 of those. But I'm going to break the 12 up into what? Perfect square times non-perfect square. 4 times 3. I get to take the square root of 4 and bring him out and join the party outside. Okay, so now he's outside and the 3's stuck. He's not a twin, he's still in jail. And then I'll go 8 minus 4 root 3, and I can't do anything more because this guy's somewhere else and he's by this root jail before. You cannot put those 8 and the 4 together. Yes, Scott? Here? Here? Because I did negative square root of 12 plus another negative square root of 12 is a negative 2 of them. Okay? Did that explain it? Okay. And then I just started simplifying that square root of 12 right away. I kind of skipped a little detail in between. Are we good? Everybody? All right, 8 minus 4 root 3 is the final answer. Now, for the great part. Radicals in your basement. And your mother told you you can't leave those crazy friends down there. So, you have to bring them back up. I need to get this radical 2 out here, but now it's attached to this 3. So I can't just multiply by the square root of 2 because then I'd have to multiply the 3 by the square root of 2. So it won't work. So this is where the new word of the day came from. We need to think of the conjugate. You're going to use conjugate pairs. So this is I want the conjugate of the denominator, which would be 3 minus the square root of 2. That's the point of what we were doing earlier, okay? All right, this is, I know it's a lot. Some of you look a little sleepy, but we got to plug along. 4 times 3, we're all excited about those class rings. Nope. Too expensive? I agree. Get one in college if you really want one. But then you'll have so many student loans you won't want to buy one either, probably. But sorry, it's just reality. I didn't get one either. I do like them though, so not to knock them. If you multiply these out, I already did the numerator, right? All right, I digress. I'm just trying to get you focused or draw you back in. Denominator, what's going to happen? 3 times 3. 3 times minus root 2, minus 3 root 2. Positive squared, I'm foiling. Right, so all I'm doing is doing what I've been doing for the last 20, 30 minutes, whatever it's been. Now I'm multiplying this. So the next one would be plus 3 root 2. And then the last one would be minus 2. Square root of 2 times square root of 2 is 2. So you see why we multiplied now by the conjugate. It gets rid of the middle term, and the radicals have gotten out of the basement. They are now upstairs. So I've got 12 minus 4 root 2, but on the bottom I still have a 9 minus 2, which is 7. And we are done with that one. Not all of them. All right, what are we multiplying the next one by? Okay, 3 plus 2 square roots of 2, or 2 times the square root of 2. All right, here we go. Distribute the 4, quick on the top. That's going to be simple. That's the part we don't mess up. And then comes the bottom. Okay, 3 times both of those. And, do you want to write the middle one? I mean, I'll show it again. I'll write it this time. 3 times 3 is 9. 3 times 2 root 2 is plus 6 root 2. And then if I do the inner, let's see, negative 2 root 2 times 3, I'm going to get minus 6 root 2. And then if I do negative 2 root 2 times positive 2 root 2, I'm going to get minus 4 times 2. Okay, does everybody know where I got 4 times 2 at the end? Bless you. Anybody confused where I got 4 times 2 at the end? That's very important. 2 times the 2, square root of 2 times square root of 2 is 2. All right, simplify. These are gone, of course. 9 minus 8 is on the bottom. Oh, 9 minus 8 is simply 1. So all we have left is the top. 12 plus 8 root 2. It's all over 1, but we don't have to write that. Ooh, a truck's going by. Look out the window, just like you would at home. No, you would not. All right, if you were doing something else, are you going to go run to the front and try to look at the little truck that just went by the house? Come on. I'm not talking anymore about the truck. 2 plus the square root of 2. You know what I'm talking about. So thrilling. Woo. 4 times 2. All right, the numerator is going to be a little bigger on this one. We're going to have 8. Oopsie. 4 times 2 is 8 plus 4 root 2 plus 2 root 2 plus 2. Okay, everybody okay with the top? The numerator? I 4 times both of those. That was the beginning. Square root of 2 times both of those. That was the second part. Square root of 2 times square root of 2 is 2. That should be at the end. All right, now I'm going to go to the bottom. I'm multiplying these and they're conjugates. I am not going to write the whole thing out this time. I'm going to remember the middles go bye-bye, okay? I'm going to do 2 times the 2, 4. And then I'm going to do minus, and then I'm going to do square root of 2 times square root of 2 is 2. The middle, remember, the whole point was it would drop out. So I'm trying to shorten this up a tiny bit. I have to combine my like terms on the top. 8 and 2 is 10. 4 root 2 plus 2 root 2 is plus 6 root 2. And then 4 minus 2 on the bottom is 2. Now, check this out. I do everything right? See these guys? They're all outside of the radical jail, so they can be reduced. If it's all 3 of these, it has to be all 3. You see over here? Even if I had a 3 down here, I could not go like that. It has to be all 3 that have something in common to divide by. Okay, so here, and I know when you were in Algebra 1, you did quadratic formula and you had to do this. It's just you're not recognizing it yet. Divide by 2 and I'll have 5 plus 3 root 2. And I'll be done. I think I did it all right. I don't know why this isn't ringing a bell for me, but it looks good. Okay, your assignment or your mission is on the next page. It is 12.5 worksheet, which is page 433. It says a book page on it, okay? Now, on the back of that is a puzzle. Oh, the puzzle's on the front? Oh, is it? Oh, I didn't even know I've had it flopped. Okay. I put the puzzle on top this year and the book page on the bottom. Right. So obviously you probably don't have your text with you. You can start looking at the puzzle, right? And get some of those started. If you want me to show you how to start the puzzle, I can, but right now I'm just going to end my recording. Do your assignment.